Welcome to the Past Security Virtual chapter. Um, this this month we're happy to have Jack Richins from Microsoft here to talk to us about securing your SQL Server environments on premises and in Azure. I want to go through a few past business items first. Uh, if you're planning to attend the summit, there's still time to save money with $150 off using our discount code PTMGM6. Want to invite you to test out all the virtual chapters out there. There's a lot of chapters for specific topics as well as cultures or languages. We do have some SQL Saturdays coming up this weekend, uh, several in North America and one in Portugal. And I want to invite you to join your local chapter. And if you don't have a chapter in your local area, you're welcome to start up one of your own. If you're interested, you can contact ce@sqlpass.org. Pass is very dependent on volunteers, and they have lots of volunteering opportunities if you're interested in helping out. Specifically, the security virtual chapter is looking for volunteers. We're looking for a volunteer meeting host, someone to send out a monthly newsletter. And if you have ideas for any other way you'd like to volunteer, we're always happy to hear from you. You can contact us at security@sqlpass.org, or you can ping us on Twitter at pass_securitybc. I want to invite you to nominate someone for the Passion Award for 2015. You can email passionaward@sqlpass.org to submit a nomination. And I want to invite you to stay involved with PASS. You can sign up for free membership today at sqlpass.org if you're not already a member. And you can connect with them on LinkedIn, Facebook, Twitter as @SQLPass, or visit them at their website at sqlpass.org. So now I'd like to turn over the time to Jack.
Okay. Okay. Are you guys, is this showing up?
Yep, we see you.
Okay. All right. So I wanted to talk today about some of the things we've learned here in the Azure SQL database team from operating SQL Server online and achieving several different compliance standards. This, in some ways, we're a lot newer to this than many of you may be. At least for my personal experience with this, I only started getting involved in 2012. Prior to that, I had worked with customers who were trying to achieve compliance and running into issues, but that's a very different experience than going through it yourself. And so in that sense, we're kind of new to this, but in another sense, as I think you'll see quickly, we had to ramp up very quickly, and we got hit pretty hard. I know we don't have, is there any way to show any kind of voting or anything with this? But I just kind of wanted to get a sense, have most of you been through some kind of compliance audit before, whether it was an internal security audit or an external vendor that came in and audited you for like PCI or things like that? Is there any way to get that kind of feedback from the attendees?
We would need to set that up before the presentation started.
Sorry about that. Sorry about that. Well, that's kind of what's on my mind because let me go ahead and advance here. So for SQL database, as I mentioned, and I got involved in around 2012 with a FISMA compliance audit and preparing for that. Right now, if you go to the Azure Trust Center, we keep a matrix of all the different services and all the different compliance standards that we go through. And we get audited continuously. You know, FedRAMP's one of the big ones, PCI, SOC is also very intensive, but there are several different audits that are going on all the time, whether it's ISO, HIPAA, EU Model Clause, Australian government, Singapore, the FBI CGIS standard. It's just absolutely continuous, and it never lets up, and we are constantly being monitored by externally, where they come in and they interview us and they review our evidence and they go over our logs with us and everything that's going on, and it's just one right after another. It literally is continuous. So this is where I say, although we've only been doing this for a couple of years, and I know some of you may have you know, decades or more of experience with different compliance standards, it's been a very intense 3 or 4 years for me personally, and I've learned a ton, and the team has learned a lot. And so we wanted to talk about some of the things we learned that we thought might be more broadly applicable and might be of some benefit to you. Now I've asked the host to just go ahead and interrupt me. If you guys have questions, just go ahead and type those out or get those to the moderator, and we'll just address them as we're going through. I don't have a ton of slides, so this could go quickly unless you have a lot of questions, or unless I get sidetracked telling stories that I probably shouldn't tell anyways, but we'll see how it goes, okay? So feel free to interrupt. For us, where everything begins is really the security plan. And this is something that we spent a lot of time on as we were both designing the service and as we make updates to the service. We really begin with the plan. We have these documents, they're centrally located. We have to review it regularly, partly because of all of these audits we're going through, and partly as we're making changes to the service, we need to go and review what did we document before, how is the change we're making going to impact the security stance of the service, you know, is this impactful or is it minor? Something that really helps us with this and was good for us is we already came with a background of SDL, the Security Development Lifecycle. This was spun up at Microsoft back in the early 2000s, back when we were getting slammed with viruses and vulnerabilities. Bill Gates kind of stood up and hired the right people and got the right people with the right mindset to really say, we need to be very methodical about how we build software so that we can be secure from the very beginning. And that's the good news. SDL is a huge benefit. It gets us in this mind frame of thinking through the security stance of everything we're doing and reviewing it and being thoughtful about it. We go through and we do threat analysis and really think about what are the assets, what are we trying to protect, and what's the attack surface area, and what can we do to mitigate things. So that's the great news. That really helped us in designing the service and in operating it, and that helps a lot of the audit questions to go very smoothly. The bad news is we are a cloud service and we're extremely agile, and there is a tension between agile and security plans and SDL, and I am not aware of any magic bullet here. If any of you are aware of one, please let us know. Right now it's just brute force, and you know, as we made the transition to Agile, frankly, a lot of the checklists and things that we used to do when we were on a ship cycle of every 3 to 5 years just didn't work. We fully were aware that we couldn't let security go, but it really just kind of changed things and changed people's mindset, where when they're thinking about designing and implementing and shipping a feature in 2 to 3 months, it's easier for them to forget things, and they use much shorter checklists. Security is still on that checklist, and they still have to go through it. But it's a battle, and it's a frustration by the teams where they're like, oh, I have to slow down and do a threat review. And it's like, yes, you have to do a threat review. You can't just ship this. And we've instituted kind of multiple checkpoints, because although we can check into our main line of code pretty much at will to keep things moving quickly, we carefully review what goes into production and what goes into our pre-production environments. And so there's kind of two main checks that happen with this. The team itself is supposed to go through SDL as part of designing the feature, even though they're on very rapid cycles. But as a second checkpoint, as they go to get those bits moved into pre-production and get them lit up, we have senior managers that are reviewing everything, and they're supposed to, be a second check to make sure, you really went through all the security checks, right? And so we try and double check it, but it's difficult, and there's a tension there, and I eagerly watch news and read other people's blogs about how they reconcile this tension between moving quickly and remaining secure and compliant. And I haven't seen any magic bullets. It's just work. You just have to keep on top of it. Now, another part of the security plan is keeping an inventory, and this spans everything from hardware, physical assets, all the way to all the logical assets we have. Azure SQL DB itself runs on top of lower levels of Azure, such as Azure Compute and Storage. So a lot of our resources are logical, but we still need to keep track of them. We coordinate closely with those teams to make sure any critical patches that need to be in the VMs are there. I mean, they're watching that themselves, but we coordinate closely with them. We have to keep on top of our own security patches. We have a system that actually kind of favors us at the moment, because, as I mentioned before, all our code comes out of this main line. As soon as Microsoft becomes aware of a vulnerability, we check in the fix to our main line first and then port it to other releases that need it, whether it's 2014 service packs or 2012 or earlier. But it goes into our main line first, so it almost always hits Azure SQL database far before it ever shows up in a security patch for SQL 2012 or 2014. In addition to this, we have to do regular scannings. Virus scans are just running continuously in Azure. And this is something where we benefit ourselves from the Azure platform, where they're taking care of the OS patching, they're taking care of the scanning for viruses, and we just hook into those systems and take advantage of it. But this inventory and just keeping track of what bits are where and what hardware you have and what network surface area you're exposing is just really critical, and we're constantly being called on to produce reports and evidence for all of this. Access control. I'll be honest, when Azure started getting serious about compliance and said, hey, we're going to go do this, as a security engineer, I had all these grand visions of, oh, we're going to have to go build all these new really advanced security features to lock things down and have these magic controls that will really protect our customers' data. And it turned out to be much simpler than I thought. I think for background for this, one thing to keep in mind is that the biggest threats most people face today are variations of APTs, advanced persistent attacks and threats. And a key word in that phrase is the P, it's persistent. These are attackers that are there for a long period of time. And it turns out that changing our access control to introduce time as an element of permission dramatically reduces all the threats. So one of the big things we do is all access to any of the Azure resources that we control and manage in Azure SQL database are governed by a just-in-time system. We have a set of jump boxes, and to get access to the jump box, we have to go through this JIT system where we input the incident ID of what's going on. We get multiple approvals from managers and others to verify that yes, there's a real incident, and yes, this person needs access to this resource. And then we also have to produce multiple factors of authentication, whether it's a phone factor or a smart card. And the JIT system behind the scenes goes and creates on the fly special accounts for us to go and access these systems. So we authenticate that we really are who we say we are to this JIT system. Then it gives us on the fly credentials to jump boxes that let us then access the Azure SQL DB environment. This is the single best thing we did in really controlling our surface area and the ability of people to attack us, and it's huge. It gives us a lot more confidence about what's going on. There's a lot of attacks out there where they may compromise someone's laptop or their tablet or phone device, but with this kind of JIT system and multi-factor authentication, we have pretty high confidence that they're not using that to leverage persistent access to Azure. You know, in addition to this, we of course have audit. I'll get to that in a moment. But this is really key. I would say this is the single biggest thing we did to really lock down the environment and make our security real. All the data is kept inside this environment, so there's no way to get access to the data without JITting in, except when it's filtered according to our online agreements. And there's a lot of details there around what we protect, etc. But there are some very filtered, abstracted logs and data that we do allow to come out through reporting mechanisms, but the data itself all stays inside the environment. And these logs are all metadata about how the system is running, right? Now, in addition to that, we of course have role-based access control. We have security groups and roles inside SQL Server. We're not doing anything here that's special beyond what you guys could do yourselves, but we do craft custom roles and craft the security permissions there to be just what we need, and we review these groups regularly to make sure no one's over-provisioned. And of course, as I mentioned earlier, no one has access to these persistently anyways. It's all just in time. So we do all of that. Another thing we do that really protects things is we tightly control access to our source control system. And we are monitoring who can check in code. We're producing regular builds, and these builds themselves get signed and scanned for viruses. And then our deployment system is checking these signatures to make sure we're only deploying from well-known build locations, signed, secure bits that then get deployed to production. And we're using the same Azure deployment mechanisms, but we've wrapped it with a few extra checks to make sure we're getting good bits out to the system, and that we're validating that the bits deployed on those nodes match what's on the build. And then finally, we have audit ACLs that are set on all of the OS images that we're running on top of, as well as inside SQL database, so that if anyone comes in and while they have JIT access is doing something with the system, we can see every single statement and command and process they run, and those get reviewed manually anytime happens. We also, I should explain that a bit further. I think I may have this in a, security auditing. I go over it in this next slide. Like I said, we're auditing all the time. The amount of data we generate is just unfathomable. We've had auditors come in from some of the standards, and this is their first time doing a cloud service, and they will ask us for all of the audit logs for a month. And we explain to them how big that is, and chuckle and then they say, well, could we get it for a day? And we tell them how big that is. And then they say, okay, how big of a window can you look at a time? And our tools, even with things like Data Lake and Hadoop, we have to craft our queries usually to look at 1-minute windows, because otherwise we overwhelm any client system trying to retrieve the data. This is a massive amount of audit data that we're keeping and we're collecting and preserving it, and we're using the same systems that you see publicly, things like Hadoop and Data Lake to store and query over these things. And we can query for them if we know what we're looking for, if we want to go look at for patterns, and we do that. We have a team here at Microsoft that works with all of Azure trying to look for anomalous behavior, and I know there's third-party tools that will do similar things. So we are looking for anomalous patterns, but it's patterns at scale. No one's coming in here and looking at the minutia of what goes on, with one exception, that we have these alerts that we've designed for risky activity. Statistically, none of you have probably ever had a Microsoft engineer touch your database, but if you flip that around and look at how many, hundreds of thousands of databases there are, periodically we do have to go in and hand fix something in a database or correct things. And as I mentioned, they go through a JIT system to access that. But once they get in, on top of that, alerts will fire so that we force a human to manually review every statement that gets executed against that database to make sure it's in line with the incident and nothing else is going on. So we rely on alerts there, and we do look at all the events around that type of a session. But it's a very different system. So we're kind of alert-based to go in and drill on very specific activity, but other than that, we're relying on these data warehouses and data scientists to go and discover abnormal activity. Now, as I mentioned earlier, we know there are third-party tools that do similar things, and if you're hosting well, frankly, if you look around at some of the attacks that have gone on with Sony, if you believe you're a potential target of anyone, they could be using APT attacks, and the best way to detect them is looking at your entire environment, not just at any one area. And I think that's why you see SEIMs taking off and so much focus on that, and then threat detection products, because you really need to kind of gather your data across all of your network and trying to find these loose threads of, well, this one event here looks a little odd. It's not that odd on its own, but when you correlate it with this network traffic and where it's coming from and where it's going to, and then you go see this one other activity on this destination server that's a little bit funny, you start piecing that together, and that's how you find an APT. And so you really need to look at your entire environment. You can't just go in and look at only the database audit. You need to look across your enterprise. Availability, this isn't something you normally hear in a security talk, but it's a huge part of compliance. I'll just mention briefly, since we're based on SQL Server, we are using always on inside Azure SQL Database as our basic failover mechanism, and we rely on this all the time. Our servers are pretty reliable, but because of all the patching that goes on at the OS layer beneath us, and then also our own deployments, we've partitioned everything into these fault zones and upgrade zones, so that if you have a database on SQL DB, you actually have multiple copies with always-on replicas, and each replica will be in a different zone, so that if we need to deploy, we can deploy without paying attention to what's going on, because we'll just take down one of your replicas, fail over to another node, and then update the node that we took down, bring it back up, and have it rejoin the always-on group. There's nothing special about that. I'm not going to spend time talking about always-on. It's very publicly documented. But the one thing I will emphasize is, in addition to this, we also have regions in Azure, and we exercise full failovers. And it's surprising. You think you've gone through every single detail and you know exactly what to do, and you have very detailed documents about what you're going to do. But until you've actually done it, you don't know, and when you do it, you will learn something new. This is a compliance requirement, and this is one of the requirements that I think is just really brilliant because we always learn something. Now, we do have an advantage in Azure because of our growth. Something we can leverage is we're constantly standing up new clusters, and so to avoid the cost and disruption it can cause to our customers, what we will do is when we're building out a new cluster, we'll redirect customer traffic there so that there's, within region, so we're not violating any of our agreements with customers, but we'll kind of duplicate customers unbeknownst to them so they have extra copies of their database on this new cluster. And then we will crash the cluster and try and rebuild it as quickly as we can and see what happens. The customer isn't impacted by this because they still have the real cluster, the production cluster that they're paying for. But this secondary cluster, we just run through our all of our documentation of rebuilding the cluster, and we do postmortems and figure out what we missed and what went wrong and what took longer than expected, and we update our documentations. But we have to do this regularly to maintain our compliance, and it's a good thing because, as I said, we always learn something, and it helps us feel a lot more confident that we are really ready for a real-world worst-case scenario. So, secrets. Just a couple of things I would highlight is it's critical to really centralize any secrets you have and have common reporting around them, whether these are TLS certificates, passwords, cryptographic keys. Any secret that you're relying on in production, we have found it to be just absolutely central or critical to have it in a central location and to have common reporting across all the secrets that documents when they're going to expire. And then we have alerts based upon it. And then you need to rotate ahead of schedule. If you have a compliance requirement that every 2 years you need to rotate a certificate, 90 days before that expiration, that's our drop dead date to rotate it, and we try to rotate it 120 days before. And we do this to make sure that we have time to deal with failures or if we need to roll back. And that's a key part of this is anything we're rotating, we keep a copy of the keys in escrow, and we make sure we have the ability to roll back changes. We also keep track of metadata around each of these secrets so we know what they're being used for, where, and the criticality of it and the impact of those certificates. And that way we can prioritize not only the order that we rotate the secrets, but also the time of day and things like that so that we can try and minimize impact in case something's going wrong. One thing you can do to mimic this is in SQL Server, use EKM. If your company is invested in an HSM or a network HSM that allows for central management of keys, go ahead and use that and root everything you can as far as your secrets in that. Pen testing. We were doing pen testing before we had to do compliance, but so in a way it's not directly related, but this is something that definitely comes up as part of our compliance certifications. The way we do it here is we have two teams. We have a red team that they're the pen testers. They're trying to infiltrate the system. And then the blue team is just our security team. And they're looking at the audit logs. They don't even know that a pen test attack is going on. What happens is the red team, they have to fill out a plan, and they even will they'll create their own dummy resources so we're not attacking any customer resources, but they'll come up with a plan, and if necessary, if they're going to try and attack quote unquote a customer database, they will create their own subscription and their own customer, and they'll go attack themselves, but it's live in our production system. And this gets reviewed with our the team that enforces SDL. They review everything. Upper management is made aware of it. They sign off on it, but this is all not unknown to the blue team. And then they go off and execute it, and they keep detailed records of what worked and what didn't. They go through and they try and break in and try and brute force things or side channel attack things. They'll try and do social engineering. Everything is free game as long as it's been approved by management and it doesn't compromise our real customers. And then the blue team is sitting there trying to use all of our security systems and trying to detect them. And this is huge. With the amount of auditing and compliance that goes on, and because of the scale of the data and the systems that we're dealing with, we can afford to employ a full-time red team. But, but for a lot of you guys, if you can't afford a full-time team, it's still worth it getting a contractor or a consulting company to come in and do a pen test. So this has been something that's been really helpful and help us to focus on the real-world threats and the things most vulnerable in our system, and to kind of have an outside-in look at our security to make sure that everything we've modeled ahead of time as far as threat modeling and going through SDL is appropriate. And so this is a great thing to be doing. I just realized what those chimes were that I was overhearing on my laptop here is people tweeting stuff I'm saying. So it's cool. So that ends what I prepared. At this point, I really want to open up for questions, because part of this is I really hope this would be a bit of a conversation. I think there's things we have learned that some of you may think is obvious, other things that at least they were new to us. However, I also acknowledge we're a little bit of a different environment. So I'm also interested, what are your challenges? Because right now it's a common security team between Azure SQL DB and SQL Server, and we're definitely, everything we've done in SQL DB, we've kept an eye towards, what can we push back into SQL Server that will make it easier for our customers on SQL Server to secure things, to become compliant. So I definitely want to hear from you guys. What are the challenges you face in achieving compliance? What certifications do you struggle with? If you're interested in Azure SQL Database, are there certifications there that you think would be helpful? And if we don't have any questions of that nature, we can open it up to any questions about security at all from the previous talks or other questions you have.
So if anyone out there, go ahead and enter them into the comments section of the GoToWebinar. In the meantime, I have a couple of questions for you, Josh.
Okay.
The first one, the just-in-time provisioner of IDs to access production.
Yes.
Is that provided by a Microsoft product?
So the specific one we use in Azure SQL Database is it's an internal implementation and system. But I know from looking at other vendors and some of the evaluations we did, there are external systems that are available. No specific names come to mind right now, but most of them are geared towards the operating system, right? And that's pretty common, and you can make that work, because one of the things you can do is, rather than making a domain user or a domain group or a sysadmin in SQL Server or other high privileged server level role, what you can do is use this JIT system, have it create a custom on-the-fly account on the node locally, and map built-in administrators to whatever role is appropriate in your SQL Server, whether it's sysadmin or whatever. And what that effectively gets you is, at runtime, by default, no one has access to that SQL Server or even the operating system, that node that it's running on top of. But on the fly, you can go through this JIT system and it will create a one-time password and user account on that local Windows box. You connect to that account, and then you can connect to SQL Server from that local node. And I've seen other third-party systems that do this. Again, I just don't have any names top of mind.
Thank you. The second question I had was with regards to certificates. You mentioned rotating them prior to their expiration. Obviously, SSL built-in expiration, but certificates that you create within SQL Server, you specify what that expiration date to be. Do you have a standard far ahead that expiration date for SQL Server certificates can be?
So what we recommend to everyone is following NIST standards for encryption certificates and asymmetric keys. And at the Azure environment, because of the number of competing standards that are there, we have there's some unique requirements for us. So I don't know that our specific rotations are necessarily good, because it gets very interesting. You have some standards that say you should not keep data readable longer than 90 days, and then you have another standard that says you must keep it for 2 years. And so we go in and negotiate with the auditors and say, look, we have to have one thing that works for both, and what can we do, and how can we compensate with other controls? So some of that will depend on your environment and what standards you have, but most standards refer to NIST, and NIST recommends a maximum, off the top of my head, I believe NIST is a maximum of 2 years for using a encryption key to write new data, and then they give you a maximum of additional 3 years to read data. So what you could envision is a system where you use a DEC and a TDE certificate or asymmetric key to encrypt data using TDE for 2 years, and then you back that up, and you're allowed to keep the backup for another 3 years with the old key and certificate, and that's fine because you're not writing any new data. Does that answer your question, or?
Yes, it does. Thank you. No other questions have come in at this time.
So no other questions? Any questions about security at all while you have me on the phone?
No, it looks like no questions.
Okay. Well, it looks like some of you guys already know how to find me on Twitter. I don't know if that was part of the slides or not, but feel free to reach out to me through Twitter if you have other questions that come up later, or if you run into issues with SQL Server or SQL DB security in general. And good luck with your day jobs there, and talk to you soon.
Great.
Hopefully I'll see some of you at PASS. Okay.
Thank you.